So Tuesday we looked at two different uses of the variables. We looked at that, just a place value for an unspecified number, and that was when we were looking at translating English words into the algebraic sentences. Things like 7 times the difference of a number and 2. Looking at this, we first off have 7 times something. Computer's acting up this morning. So 7 times something. We're multiplying 7 times something, but what are we multiplying?
7 times a number plus 2.
Yeah.
7x plus 2.
Well, remember, careful, it's difference, right? Yep. Yeah. And first of all, difference means subtraction. And yeah, it means that's the result of a subtraction. So we have to have parentheses. We're not multiplying the number, we're multiplying the result of the subtraction of the number and 2. So whatever letter we're asked to use, let's use D for the number. So D minus 2. So it'd be 7 times D minus 2, or just 7 and the D minus 2 in parentheses. The other thing we used our variables for was for formulas. We were asked for evaluate an expression. So we might be asked to evaluate 7D minus AP for D equals 8. That's the easy way. A equals 3, and P equals 5. So that means we first have to replace each of these letters with the specified value. So 7D becomes 7 times 8. Very good. And even though it's just 7D, it is 7 times D, so 7 times 8. AP becomes 3 times 5, yes. AP means A times P. So that's 3 times 5. And now it's a matter of order of operations. What do we have to do first? We're going to multiply. We're going to go left to right. 7 times 8, 56. And then 3 times 5 is 15. And all that's left is the subtraction. 56 minus 15 is 41. So when we evaluated that, we get 41. When we're given that command or that request to evaluate, we usually will be able to get it down to a single number as our answer. Different from that, though, we might be given the command to simplify. And simplify means combine what you can combine, but you're probably not going to get it down to a single answer. So we might be asked to simplify something like 9x to the 5th minus 3x squared times 7x to the 3rd minus 5x plus x to the 3rd. So simplify means combine what you combine. And remember, the tough part with these is knowing when to stop. First, it's just an order of operations problem. I see parentheses. Is there anything I can do inside the parentheses? Can I combine any of that? Say no. No, we can't. So our next step is to see, is there anything we can do to the parentheses? And there is. It's multiplied by what? You have to be careful. It is a negative 3x squared, or 3x to the second. So let's go ahead and multiply what's through the parentheses, or distribute, if you will. Negative 3x squared times 7x to the third is negative, perfect, negative 21x to the fifth. Negative 3x squared times negative 5x. Positive 15 x to the third, yes. And then the rest of the problem is still there. The 9x to the fifth and the plus x to the third. Now what? Sure, we will combine the x, and usually we focus on the highest power first. So the x to the fifth is the highest power. We can combine 9x to the fifth and negative 21x to the fifth. 9 and negative 21 make negative 12. Good. And then it's x to the fifth. Because we are just adding or subtracting there, the name doesn't change. It stays x to the fifth. Then over here, 15x to the third plus x to the third. Or we think of that as 1x to the third, right? So 16x to the third. Very good. And that's it. We cannot go any further. I will catch at least one of you on the first test next Tuesday, combining that negative 12 and 16 is 4, and don't do that. You are done right there. That's as far as you can go. Well, today we're going to go on to that third use of a variable, and that is it's representing a specific number that we need to find. And it is something like this. X equals 7, of course, is called an equation. And a key to an equation is that symbol right there, which is called equal sign, yes. Now here's the tough one. Without using the word equals, define what that symbol means. Is, yes, same as. Same value. What it means is what's on one side has exactly the same value to what's on the other side of that symbol. In fact, you can think about it as being like a balanced scale. What's on one side of the equal sign exactly balances what's on the other side of that equal sign. Now, all equations that we work with start out in this form right here, as a variable equals a number. And they're built from there. If you're a car person, kind of like having the frame and you build it up from there, or computers, you have the box and you start with the connections and build them up from there. Equations start in this form. A variable equals a number, or a number equals a variable, and they're built from there. So some things we can do mathematically to build onto this equation. Well, we have our basic operations we've talked about. Add, subtract, multiply, divide. Now there will be other basic operations that come into play, powers and roots, not so basic operations that are beyond the scope of this class, exponents and logarithms, trig functions and their inverses. There are all sorts of math operations out there that can be done to build on this equation. For our purposes, we're going to focus today on the big four, add, subtract, multiply, divide. But we will bring in at some point the powers and roots, and that's as far as we're going to go for this class. But here, let's build onto this equation by adding. Somebody give me a number between 1 and 10. 8. Very good. So if we add 8, now, I shouldn't get ahead of myself. We add 8 to our variable, that becomes x plus 8. But now because this is a balanced scale, if I add 8 to one side, it's going to tip unless I do what? I have to do the exact same thing to the other side. I add 8 to the other side. So 7 plus 8 makes 15. I have now built a more complex equation from that basic equation. Well, the command that we are usually given as it relates to equations is the command to solve. Solve basically means take it back apart. So this equation was built by adding 8. What would we do to take it apart? Very good. The opposite of adding 8 is subtracting 8. So if we subtract 8, that removes that plus 8, leaving us with x. Now, just like we saw up here with the balanced scale, if I subtract 8 from one side, I have to do the exact same thing to the other side. So 15 minus 8 is 7. I am now back to that original form of a variable equals a number. And when we're solving, when we're told to solve, that's all it's asking us to do is to take that equation apart and get it back to that simplest form of a variable equals a number. Now for this equation, we built it. So we knew it was built by adding 8. Most of the time, we're not building our own equation. We're looking at equations that have already been built for us. And the tricky part is figuring out how it was built. So let's take an equation like 7 equals y minus 4. To figure out how an equation has been built, first thing we do, find the equal sign. Right there's our equal sign. Next thing we do is we identify which side of the equation or which side of the equal sign has the variable. That's this side over here. Now on that side of the equation, we have two questions we need to ask. Question 1, what is keeping our variable from being alone? Well, in this case, what's keeping my y from being alone? The 4, yes. The second question is, what operation was used to build it on? Really poor grammar there, I know, but what operation was used to build the 4 onto the equation, or to attach that 4 to my variable? It was subtracted, right? So now that we've answered those questions, the 4 was subtracted from the y, and that's what's keeping it from being alone. How do we take that apart? How do we reverse that? Yeah, the opposite of subtracting 4 is to add 4. So that is now gone. All we're left with on that side of the equation is y, the variable. But if we add 4 to one side of the equation, we must do the exact same thing to the other side. We add 4 to our 7 to get 11. So 11 equals y, or y equals 11. Now with these equations, we can always double check ourselves. In fact, my math lab in some cases will ask you to go through the steps of checking the equation. If we did this correctly, 11 equals y means we should be able, just like evaluating our expressions earlier, we should be able to put 11 in where the y is, and this equation should be true. So instead of 7 equals y minus 4, it's 11 minus 4. So we can't do anything on the left side. That's just a 7. 11 minus 4 is 7. So we get the same value on each side. So that's true. So that tells us that's most likely the correct answer. Bless you.
Okay.
We might have 7z equals 35. We go through the same process. We find our equal sign right there. We identify which side has the variable. Well, there's my z, so that's the side with the variable. And then it's time for our questions. What's keeping the z from being alone? The 7 is. What operation was used to attach that 7 to the z? Multiplication. Z has been multiplied by 7 to build this equation. So to take it apart, how do I reverse multiplication? Divide. Very good. Very good. We divide by 7 to get rid of that 7, leaving us with just z. And of course, as we've mentioned, to keep that scale balanced, we have to do the exact same thing to the other side. We divide by 7. 35 divided by 7 is 5. Z equals 5. And we can double check if we want to. 7z becomes 7 times 5. Does that equal 35? Yes, it does. Now, a lot of times when I divide in equations, rather than writing it out with the divide symbol, I just put the fraction bar for divide. So when you see that fraction bar, it means the exact same thing. It's just a quicker way of writing it out. So P over 3 equals 9. So again, you find the equal sign. You identify which side is the variable. That's on the left side here. What is keeping the P from being alone? 3. And what operation was used to attach the 3 to our P? It's been divided. So how do we get rid of it? Multiply. We multiply by 3. We'll cancel it dividing by 3. Leaves us with P. We have to do the exact same thing to the other side. 9 times 3 is 27. And again, I can always replace my P with the 27 to make sure it works. 27 over 3, does that equal 9? Well, 27 divided by 3 is 9. So yes, it is true. These, what we call one-step equations, and they're called one-step equations because they were built in one step. Only one operation was used to build those equations. They can be solved in one step. We only have to use one or reverse one operation to solve the equation. Most equations are what we call two-step equations. Oops. The most common equation you will solve has two operations required to build it. There are equations with more operations than that, but most of the time they can be simplified or reduced to two-step equations. So a two-step equation might look like this. To solve it, we go through the exact same steps. We find our equal sign. There's our equal sign. We identify which side has the variable. Well, that's over here. And then we ask ourselves, what is keeping the variable from being alone? And then what operation was used to build that on or attach it. In other words, what we're asking is what has been done to my variable, to x, to build this equation. Well, we have, let's go through those questions. What's keeping x from being alone here? 3 and the 2. What operation was used to build the 3 on?
Multiplication.
It was multiplied in the 2. was subtracted. Now, order of operations tells us if we have a number there for x, which one do we have to do first? Do we multiply first or do we subtract first?
Multiply.
You multiply. So this equation was built, the variable x was first multiplied by 3, and then 2 was subtracted from it. Now, if you think about putting something together, if you put together a piece of furniture or anything that you want to assemble, if you've just finished putting it together, you've put on that last piece. If you go to take it apart, what's going to be the first piece you have to take off? The last piece you put on. Same thing with the equation. When you take something apart, you have to go in the backwards order. You have to first remove the last piece that was put on, and then go backwards from there. So here the last piece that was put on was subtracting 2. So what do we have to do to get rid of the subtracting 2? Add 2. And we have to make sure we do it to both sides. Over here, adding 2 is removing that subtracting 2, leaving us with 3x. Over here, 25 plus 2 is 27. And then we have to get rid of the multiplying by 3 by divided by 3. There we go. So that cancels out that divided by 3, or removes the multiplying by 3. 27 divided by 3 is 9. And again, we can double check these, replacing x here with 9. So instead of 3 times x, 3 times 9 minus 2 equals 25. And let's see how that comes out. Well, 3 times 9 is 27. And 27 minus 2 is 25. So yes, 25 does equal 25, so it's true. Any questions? Let's do one more together. Yep. I do that on purpose. A lot of people get stuck in the rut of the variable always being on the left side. Now, we work with the variable no matter which side it is in the equation. So we find our equal sign. It's right there. We identify which side has the variable on it. That's our right side. We look at what has been done to build the equation. Well, what was the first thing that was done? X was multiplied by 5, and then 7 was added to it. So when I go to take that apart, what's the first piece I have to remove? Yeah, we're going to get rid of the 7, so we're going to subtract 7. Very good. So that piece is gone. We have 5x left on the right side. 22 minus 7 is 15. The next piece we have to remove? Divide by the 5. Very good. So 15 divided by 5 is 3, so 3 equals x, or x equals 3. Any questions? Okay, I'm going to give you guys a couple of these to try in your notes. (7y minus 1 equals 41) and 2y plus 9 equals 27. So I'll pause the recording and let you guys have a couple minutes to try those. Take a look at the one on the left here first. 7y minus 1 equals 41. Now we're just going to jump right in and solve this. What's the first thing we have to do to solve it?
Add 1.
Add 1. So that takes that piece away, giving us what?
7y equals 41.
7y equals 42. Okay. What's next?
Divide by 7.
Divide by 7, which gives us
y
y equals 6. Good. And we could go back and replace y with 6. So 7y becomes 7 times 6 minus 1. If we were to double check that, 42 minus 1, which is 41. On the right side here, 2y plus 9 equals 27. What do we do first? Subtract 9 from both sides. Giving us 2y equals 18. Good. And then? Divide by 2. Very good. Which gives us y equals 9. Great. And I'm going to trust you guys can plug it back in and double check it. Okay, so these can get a little bit more complex. Many of the problems we work with will have that variable appear more than once. All of these two-step equations, as we call them, that we've worked with, the variable only appears one time in them. What if it appears more than once? What if we have something like 3x minus 7 plus 2x equals 38? Well, we think of this as that balanced scale that we mentioned. This being a balanced scale, and the 3x and the 2x are on the same side of it, could I just take and push them together to make one big pile? Would that change how my scale balances at all? Is it okay to just push them together?
Yes.
Yeah, it could. They're on the same side, right? They have the same name, 3x and 2x. So if I can combine 3x and 2x makes 5x. So 5x minus 7 equals 38. It's the exact same equation. All I have done is I have simplified it. When we are asked to solve an equation, often the first step is to simplify. Sometimes we simplify just one side, sometimes we simplify both sides. So when you simplify, you have to look at each side separately. And we're going to look at some where we have to combine things on two sides. We'll look at those in a little bit. I'm just going to say that's combined between sides. And then after we have simplified, then we can take it apart. In other words, solve it. So what we just did here, this first step, we weren't really solving the equation so far. We were simplifying it so that we can solve it. Because we have to have it in this two-step form here before we can solve it. Now that it is in that form, what is our next step? Add the 7. Very good. What does that give us?
5x equals 45.
5x equals 45. Good. And next?
Divide by 5.
Divide by 5. Giving us?
X equals 9.
X equals 9. Good. And we can double check this. Going back to our original equation, replacing each x with 9. So instead of 3x, it is
3 times 9.
3 times 9 minus
7.
7 plus
2 times
2 times 9 equals 38. And so we can combine. What's the first thing we have to combine? 3 times 9 makes 27. And now here's one where we could have multiplied the 2 and the 9 on the same step and it wouldn't hurt anything. But sometimes that can give us problems. So to be safe, I'm going to do it as a separate step. So the next step is multiplying the 2 and the 9.
Isn't that 18?
Yeah, it is 18. Little hamster isn't on the wheel yet today for some reason. I'll be honest, some days he refuses to get on the wheel. He just lays beside it and tries to swat it with his paw and hopes it goes fast enough. This might be one of those days he never completely gets on. So, what's our next step then?
Oh, subtract.
Yep.
Subtract the 27 from the 7, or the 7 from the 27?
Yep, and that is it. We have to do the 7. 27 minus 7 is 20. And then we can add the 18. 20 plus 18 is 38. Which, of course, does equal 38. Now, for some people, it gets confusing having this term on the end here. So if you want to drop that and just write this part until you get down here and get 38 and then go back and compare and see that it matches that number. For a lot of people, that's simpler, not having to write that equals because they think they've got to do something with that 38 over there, and you don't. All you're really doing is order of operations on this piece right here. So we had that type of problem there. How is that different from this problem here? The variable appears twice. But the difference in this one is
On either side of that equal.
that's once on each side of the equation. Can I push the 3x and the 5x together to make one big pile here?
No.
No, because here's my scale. They are not on the same side. I can't push them together in a single pile. So I am going to have to figure out some way to get rid of one of them. And to do that, I usually get rid of the smaller one. Which one's smaller here?
The 3x.
The 3x is smaller, yes. Now, mathematically, getting rid of something involves something called inverses. Inverses, we've actually been using those to solve these equations so far. I'm going to scroll back up here. Right here. This was subtracting 1. The inverse was adding 1. So adding and subtracting are inverses. Y was multiplied by 7. To get rid of it, we divided by 7. Multiplying and dividing are inverses. So we have pairs of inverse operations. We have addition and subtraction. And we have multiplication and division. There's a difference between what they do, however. If I use an addition and subtraction inverse, so I had minus 1, and I got rid of it by doing plus 1. What was my result that I got? 0. So if I do adding and subtracting, I get 0. When I multiplied and divided, here I was multiplied by 7, I divided by 7. What do I get there?
1.
Yeah, technically that's a 1y. So when I use multiplication and division as inverses, I would get 1. So coming down here, I'm going to get rid of the smaller one, which is the 3x. Do I want it to, when I get rid of it, do I want it to be a 1 sitting there or a 0? I want it to be a 0. I want it to be nothingness, which is 0. So to get rid of it, I am going to subtract 3x, because that will leave me with nothing, or 0. Right? So what I'm left with is 21 there. Now again, just like our other equations, I did something to one side. So that scale is going to tip unless I do the exact same thing to the other side. Bless you.
Bless you.
I subtracted 3x from one side. I have to subtract 3x from the other side. Now I can only add or subtract things that have the same name, have like terms. So what can I subtract 3x from over here on the right side? The 5x. 5x minus 3x is 2x, and I still have the plus 7. Now I should note here, when I add or subtract to an equation, I only have to do it to one digit on each side. 3x is a digit. I subtracted the 3x from that. I only had to subtract it from the 5x on the other side. I didn't have to touch the 7 or the 21. When we multiply or divide, it's going to be different, just so you know. So I've got 21 equals 2x plus 7. It's now in that two-step form, so we can go ahead and solve. What are we going to do first? Subtract 7, which is going to give us 14 equals 2x. And then
Divide by 2.
divide by 2, which gives us 7 equals x. And of course, we can put that back into that equation and verify that it's true. So 3x becomes 3 times 7 plus 21 equals 5x becomes, well, 5 times 7 plus 7. Now, as I mentioned before, I can work on each side of this equal sign separately here. So I'm going to treat the left side here as a separate problem. What do I do first here? Multiply. 3 times 7 is 21. And then, of course, I've got 21 plus 21 is 42. Now I'm going to look at the right side. What's the first thing I have to do there? 5 times 7 is 35. 35 plus 7? 42. So I get the same result on each side. So here, tell me what I have to do.
Get rid of the 2x.
Well, my variable appears twice. So
Combine the 4x and the negative 2x.
perfect. Yes, that's exactly what we have to do. When the variable appears more than once, there's two possibilities. Either I can just combine them, or I have to get rid of one of them. Here, because they're on the same side of the equal sign, I can just combine them. And you're absolutely correct. It is 4x and a negative 2x, which make
2x.
2x.
just 2x. Good. Now I still have the minus 3. And the left side has not changed at all. That's just 27. So again, at this point, I have not done anything to solve this equation. All I have done is simplify. Now I am in that two-step form, so now I can solve. What do I need to do first? Add the 3. Giving me 30 equals 2x. And then?
Divide by 2.
Divide by 2, giving me x equals 15. And again, I'm not going to plug it back in. I'm going to assume you guys can do that. So here, tell me, what do I have to do first?
Get rid of 2x.
Well, my variable does appear more than once. Well, are they on the same side?
No. 'Cause we
No.
can do this.
So I cannot combine them. So I do have to get rid of one of them. Which one's smaller?
Subtract the 2x.
Okay, I could subtract the 2x, but remember we said usually it's best to get rid of the smaller one, which is the negative 5x.
Oh, I keep thinking of that as a minus instead of
Yep.
5.
Well, and like I said a couple days ago, it is both. It is a minus 5x or it is a negative 5x, depending on which is easier for you to think of it as. But I'm going to get rid of it by adding 5x. Could we have solved it by subtracting 2x? Absolutely. The reason I say get rid of the smaller one, what was the thing I said that most people will struggle with throughout the whole course? Negatives. And if we get rid of the smaller one, we usually end up working with negatives. Yeah. So by getting rid of the smaller one, we're staying with the positives. So that negative 5x, we add 5x to get rid of it. What does that give us? 7x plus 7 equals 21. And then subtract the 7. So 7x equals 14. And then divide by 7. X equals 2. Any questions? Now I said we could have subtracted the 2x. It does not change our answer. It changes the process we go through to get to the answer, but it doesn't change the answer. So let's take a look at that. If I were to subtract the 2x here first, I have to subtract it from the negative 5x over here. So what, oops, this is a plus here. What am I left with on the left side here? 7
equals 21 minus
7x.
minus 7x, yes. And that right there is the first spot that usually trips people up is negative 5x minus 2x. A lot of people end up putting in a negative 3x there, and that's not correct. It is a minus 7x. Now to solve this, we would
subtract 21.
Subtract 21. So we've got 7 minus 21. Here's another spot that's ripe for a mistake. 7 minus 21 is?
Negative 14.
Negative 14. Very good. Now what's our last step going to be?
Divide by negative 7.
Divide by negative 7. Very good. So, again, another spot people don't forget to use the negative or whatever. Negative 14 divided by negative 7 is, again, a positive 2. So we do get the exact same answer. And we should, because there is only one correct answer to this equation. So no matter how we go about solving it, we should get to the same answer. It's just over here, there's 3 spots where we have to work with negatives. And I found through the years students make way more mistakes with negatives than they do anything else. Tell me what to do here.
You got to get rid of 8x.
Okay, we've got an x on each side, so we have to get rid of one. We can't combine them because they're on different sides. We have to get rid of one. And you say the 8x? Because it's the smaller one. Very good. So what do we do to get rid of it?
Subtract 8.
Subtract 8x. Very good. And so we subtract that 8x to get rid of it. What do we do on the other side? Subtract 8x from
9x.
the 9x. Very good. What's that give us?
1x minus 3
Minus 3
equals 4.
Okay, very good. Now I wrote down 1x because the first person I heard said 1x minus 3 equals 4. But I heard another person said x minus 3 equals 4.
Same thing.
It's the same thing. In this form here, though, is just x minus 3 equals 4. It saves us a step in solving it.
So we don't have to break down.
Yeah. Because to solve it, either way, I'm going to be doing what for my next step?
Getting 3.
Adding 3. So 1x or x equals 7. Well, at this point, I am done. X equals 7. Technically here, I should divide by 1 to get rid of the 1, but I don't have to.
Or 1 times 7 is also.
Yeah. So either way, I do get x equals 7. But recognize, when you have 1x, it really is just x. Oops. Let me try that again. So here I have 7x minus 2 equals 3x minus 8 plus 5x. Now here, we go to solve. I'm going to walk us through the steps here. Here's our equal sign. We go to identify where the variable is, and we see not only is the variable on each side of the equation, but it actually appears twice on the right side. When we have that case where both of those issues are there, not only is it on both sides, but it's also twice on one side. The one that we deal with first is the twice on one side. We will try to simplify each side first. So whenever we try to simplify, we're trying to solve an equation, obviously. And whenever we have to simplify an equation before we can solve it, we always try to simplify each side first. So now on the left side over here, 7x minus 2, is there anything I can do to simplify that?
No.
No. So that side we're going to leave alone. On the right side, what can I do to simplify that?
3x and 5x.
3x and 5x, which makes
8x.
8x. So we have 8x. We still have the minus 8. The left side is not changed. That's just 7x minus 2. So we have simplified now everything that we can on each side. We still have a variable on each side, though. So we are going to subtract the 7x. We have to get rid of one. Smaller one's the 7x, so we will subtract it. Now again, we add or subtract. We only have to do it to one digit on each side. So we subtracted 7x to eliminate that one, leaving us with negative 2. On the right side, we'll subtract the 7x from
8x.
the 8x, which is going to give us
X.
x, 1x or just x. And we still have the minus 8. And then
Okay. Or add 2.
add 8. Remember, we have to look at where the variable is. Here's our equal sign. The variable's over here. It's the 8 that's keeping the variable from being alone. It's subtracted, so we add it. We add 8 on the other side. Negative 2 plus 8. Perfect. It is a positive 6. So 6 equals x, or x equals 6. I'm actually glad that you did that. You said add 2, because so many people are drawn to the left side of the equation first. So they think that whatever's on the left side is what they have to work with. But remember, it's where the variable is that tells us what we have to do. That's a very common mistake, so I'm glad you did that. I'm going to have you guys try some in your notes. I'm actually going to give you 3 of them here. 5x minus 3 equals 2x plus 12. Eleven equals 3x minus 3 plus 4x. And finally, 5x minus 7 minus 3x equals if I can write here. 3x minus 13 plus x. So have you tried those three? I'll give you a few minutes and we'll talk about them in just a minute. We need another minute yet, or are we ready to go? One more minute? Okay. let's take a look at the first one here. See how you did. 5x minus 3 equals 2x plus 12. What's our first step?
Get rid of the 2x.
Get rid of the 2x, and we'll do that by
Subtracting.
subtracting 2x. Of course, on the left side, we have to subtract it from the 5x. So what's that give us?
3x.
3x
Minus 3.
minus 3
12.
equals 12. Good. What's next?
Add the 3.
Add the 3. Very good. So 3x equals 15. And then
Divide by 3.
divide by 3. So x equals 5. And again, I'm going to trust that if you guys wanted to, you could plug them back in and verify that you get 22 on both sides. The second one here, 11 equals 3x minus 3 plus 4x. What would we do first there?
Combine the 3x and 4x.
Good. We combine the 3x and the 4x. So that gives us 7x minus 3, and then we still have 11 on the left side. And then
Add 3.
add 3. So 14 equals 7x. And then divide by 7. So 2 equals x. Any questions on either of those first two? Show of hands, how many had both of the first two right? Okay. For those of you who didn't have them both right, you figured out what you got, what you did wrong? So then down to the last one. Now this last one looks like a monster. Trust me, before we're done with the summer, I will show you some that are worse. But it is just a matter of following our steps. So on the left side, what can we simplify?
5x and negative 3x.
Perfect. 5x and negative 3x, which make 2x, and what else is there? Minus 7. Is there anything else we can do on the left side? No. So we go to the right side. What can we do there? 3x and x. And we get, we treat that as a 1x. Exactly. What do we get with that? 4x. And we still have minus 13. Good. What's our next step? We have an x on each side. We do have to get rid of 1, and we will subtract the 2x. That will be gone, leaving us with negative 7 here. What do we have to do over here? Subtract the 2x from the 4x, which gives us 2x minus 13. Good. Now, remember, the variable's right here. So that's telling us this is the side we have to work on over here. What's the first thing we have to get rid of? 13. We're going to do that by adding 13. It's gone. We have to add 13 to the other side. So over here we just have the 2x. The 13 is gone. What's negative 7 plus 13? 6. Very good. And our last step? Divide by 2. Wonderful. So the 2 is gone. We have x equals 3. Any questions? Okay. that's a good time to take our break. We're a few minutes early here, but let's do it. It's 10:14. Let's come back at 10:24.